Hello, mathematicians. We are going to continue our work with showing equivalence, showing how tenths and hundredths can be equal using the area model and, in some scenarios, place value disk. So we just completed this problem. I'm actually going to go back to an old template, lesson 4, to show you this next problem that I want to focus on. So our focus in this work here is making hundredths with an area model. So I'm going to start a little bit lower. You're welcome to go back. Or, honestly, you could really make this in your notebook. And that's what it's all about. How can you use these models and make them work for you? Because when you get to a test, I'm not going to have it there for you. How can you take the steps of using the models and making use of those structures? So make hundredths with an area model. Okay, so here's a tape diagram. We used these in our last lesson, right? I mean, you can even look up here and you remember those little lines and dashes, right? So if I were to shade in, let's say one part here, and I break this into 10, and shade in 1, 2, 3, 4. I shaded in 5 parts here. What does this beautifully shaded diagram represent? Well, if I think of it in terms as a decimal, these are still in tenths, right? These are still in those chunks that when I add them all together, I have tenths. So I have 2 of those, and in the hundredths place, I have 5. So I have 25 hundredths here all together. That is how I say it as a decimal. It is written 25 over 100, 25 hundredths, and you say it 25 hundredths. We say it the same way. Both the fraction and the decimal number represent the same amount. What's different is the way they are written, and we can see that on the page here. So just as we can express it different ways, we can express it different ways pictorially, right? We have this ray representing 25 hundredths here, but if our focus is modeling hundredths with an area model, how can I go to my lesson 5 template, use some of that to model this with an area model? What does that look like, right? So I want you to think about, I'm actually going to come down here and kind of model for you a little bit on this one. When we take these lines here, right, we're dividing them smaller. We are making those hundredths pieces. So I could easily add 10 lines here, right, and make a hundredth. But what I'm going to model for you, and I'm going to do it in blue on this diagram equals 25 hundredths. And I want you to ignore what I have here, and I know that might be a little bit of a challenge to do, but I want to show you something a little bit interesting about how I'm going to do this as well. So 25 hundredths, that means that I need 2 tenths, 2 rows of tenths, which is the same as 20 hundredths, and then 5. Every year when I teach this, I have students that love to get creative on this diagram and make everything a challenge for me, because we recognize that if we're looking at the shaded part, altogether we only need 25 boxes shaded. So I can shade it down here. I can shade it from the bottom, from the top, from this side. I have some students that love to drive me crazy and fill in random boxes all over. Please don't do that. But I did want to show you on the other side of this model here, because you're shading in that part. As long as it's shaded all together, we know that 25 of these hundredths create 25 hundredths. It's all about that shaded portion. So let's think of all the ways that we could document this 25 hundredths, right? I have 0.25. I have 25 over 100, right? And I want to think about the question here as well. How many tenths are shaded? 2 tenths are shaded, and 1/2 of a tenth is shaded here. So 2.5 tenths are shaded. Just as there's so many ways to represent this on the diagram, there's so many ways you could express what you're visualizing here. So don't let thinking we're doing decimals make your brain turn off to fractions and make your brain turn out, well, what fraction of it is shaded, right? There's so many ways we could look at and interpret this. So that's how we can model hundredths with an area model.